Hello students, welcome to St. El's online classes. Students, we are working from home. So now let's look at the question number 11 of exercise 11.3. So in this question, we have given that there is a plane P1, equation given by that, and plane P2. Then through the line of intersection of plane P1 and P2, another plane through this line of intersection, another plane P is passing. We have to find the equation of plane P, that we have to find, and given that this plane P is perpendicular to the plane 3. This plane P is perpendicular to these two planes are making of angle 90, and this plane P is perpendicular to plane P3. So I have to find the equation of plane P. First of all, since plane P passes through line of intersection of plane P1 and plane 2. So the equation of plane P, that would be, we all know that would be x plus y plus z minus 1 plus lambda 2x plus 3y plus 4z minus 5 equals to 0. This is the equation. Now what we will do, we will equate the coefficient of x and y and z. So here coefficient of x here 1 and here is 2 lambda. So 1 plus 2 lambda x plus coefficient of y over here is here 1 or here is 3 lambda. Coefficient of z over here 1 and there is plus 4 lambda z. Here y will also come. Y plus z is 1 plus 4 lambda z, and that would be minus 1 and here minus 5. So that would be 1 plus 5 lambda. So this is the equation of plane P. Now what we have given, plane P is perpendicular to plane 3. It means what? That normal to this vector, this plane P, and normal to plane P3, they will also be perpendicular to each other. It means what? The multiple of their direction ratios and the sum will be equal to 0. The condition, if you remember, A1 A2 plus B1 B2 plus C1 C2 equals to 0. It would be hold over here. Here A1 B1 C1, suppose these are the direction ratios of the normal to the plane P, and A2 B2 C2 are the direction ratios of the normal to the plane of plane P3. Okay, so now direction ratio of plane P here 1 plus 2 lambda. A2 plane P3, coefficient of x is 1. Now again B1, here B1 is 1 plus 3 lambda and B2 is minus 1. Here C1 is 1 plus 4 lambda and C2 is 1, that equals to 0. So from here we will find the value of lambda. So it would be 1 plus 2 lambda minus 1 minus 3 lambda plus 1 plus 4 lambda equals to 0. Now solve it. 2 lambda minus 3 lambda minus lambda plus 4 lambda plus 3 lambda, 1 would be cancelled out. So this is only 1. So equal to minus 1. So from here lambda equals to minus 1 by 3. So this is the value of lambda. Now we will put this into equation number first and we can get easily the equation of plane. So put in equation number first. So it would be, equation of plane P would be 1 minus 2 by 3 x plus 1 minus 3 by 3 y plus 1 minus 4 by 3 z equals to 1 minus 5 by 3. Okay, so that would be 3 minus 1, it means 2 by 3, so x by 3. This would be 1 minus 1 0, so that's why it equals to 0. So I just need not write over here. Okay, here this is 3 minus 4, so minus 1 by 3, so minus z by 3 equals to 3 minus 5 minus 2 by 3. So 3 is the LCM, would be omitted from the all sides, so equation would be x minus z equals to minus 2. So this is the required equation of the plane. Students, please pause the video and note it down. Now look at the question number 12. So here we have given two planes and we have been asked the angle between them. Okay, so now compare this plane with the standard form, that was r dot n1 vector equals to 0, or here r vector dot n2 vector equals to d, sorry. Okay, so from here I can, what is the normal vector? Normal vector from here, that is 2i cap 2j cap minus 3k cap. This is the normal vector of plane 1, and normal vector of plane 2, that is 3i cap minus 3j cap plus 5k cap. And beta angle between two planes. So once we have the normal to the vector, then the formula was cos theta equals to n1 vector dot n2 vector upon n1 vector modulus and into n2 vectors modulus. Okay. So now n1 dot n2, it means what? 2 into 3, 6 plus 2 into minus 3, minus 6 minus 3 plus 5 minus 15 upon, but there is a whole lot magnitude modulus under root n1. So magnitude of n1, that would be 4 plus 9 into, and magnitude of this n2 vector would be 9 plus 9 plus 25. Okay, so here it would be minus 15, so it is modulus, so it would be plus 15 upon under root, that would be 8 and 9 under root 17 into, that would be 18 and 25, 513, 3 and 140, 43. So from here theta would be cos inverse 15 upon under root 17 into 43. So this is the angle between these two planes. Okay students, very easy question. Thus we just need to find out the n1 and n2 and just apply the formula, we can get the answer. I hope it's clear. Please pause the video and note it down. Beta, in question number 13 we have given 5 parts and we have given 2 planes, so we have to check whether they are parallel to each other, perpendicular to each other. If they are not parallel and perpendicular, then we have to find angle between them. Okay, so now first of all compare it with the standard form. So so this is ax plus by plus 0 plus d equal to 0, that is the standard form. So from here a1 would be 7, b1 would be 5, c1 would be 6 and d1 would be 30. From here a2 would be 3, b2 would be minus 1, c2 would be minus 10 and d2 would be 4. Okay student, now if they are parallel, first of all we'll check for the parallel. So a1 upon a2 is equals to 7 upon 3, b1 upon b2, that is 5 upon minus 1 and c1 upon c2, that is 6 upon minus 10. So we can clearly see that a1 upon a2 is not equals to b1 upon b2 is not equals to c1 upon c2. Hence these two planes are not parallel. So plane P and plane P2 are not parallel. Now check for the perpendicular. So a1 a2 plus b1 b2 plus c1 c2 equals to a1 a2 7 into 3 21 plus b1 b2 5 into 1 minus 5, c1 c2 6 into minus 10 minus 16. Clearly it is not equals to 0. Hence plane P1 is not perpendicular to P2. Okay, so now we have to find angle between them. So that was cos theta is equals to magnitude of modulus of a1 a2 plus b1 b2 plus c1 c2 upon under root a1 square plus b1 square plus c1 square into under root a2 square plus b2 square plus c2 square. Okay student, now a1 a2 plus b1 b2 plus c1 c2 we have already find, that was minus 65 and 21, so that was 4, so minus 44. Okay, upon under root of a1 square b1 c1 square, so 49 plus 25 plus 36 into, that would be a2 is 9, 1 and 100. So from here cos theta would be equals to, there is modulus, so there is no signs of negative, so it is 44 upon under root of, that would be 9, 5, 14 and 6, 2, 6, 8 and 3, 11, 110 into, and that would be 110. So it means what? Under 110 and 110 is means 110. So from here theta equals to cos inverse 44 upon 110. So this is the angle between these two planes. Same procedure you have to do for rest 4 question of this, for the rest 4 part of question number 13. First of all, find a1 b1 c1 d1 for both planes, for check for the parallelity. So a1 a2 b1 b2 c1 c2, if they are equal, planes are parallel. If not parallel, check for the perpendicularity. A1, A2, B1, B1, B2, C1, C2 equals to 0, then they are perpendicular, otherwise not. And if not parallel, not perpendicular, put the formula of angle between them and you can easily find angle between them. Okay students, now please pause the video and note it down. Now look at the question number 14. So there are multiple parts. I will solve only one question and the others are similar, you can solve it by them. So we have a point and I have a plane. So we have to find the distance of this point through this plane. Suppose this is our plane and the plane is 3x minus 4y plus 12z equals to 3, and suppose here is the point is 3 comma minus 2 comma 1. So what would be the perpendicular distance? The distance d. Okay, we all know that the formula of distance of a point through to a plane is given by modulus of ax1 plus by1 plus cz1 plus d upon under root a square plus b square plus c square. Here a, b and c are the direction ratios of normal to the plane. It means what? 3, minus 4 and 12. And x1, y1, z1 are the points of the coordinate. It means what? 3, minus 2 and 1. So we have all the values. We just need to simply put in the formula. So d equals to under ax1. So a is 3 into x1 is 3 plus b is minus 4 and y1 is minus 2 plus c is 12 and d is 1, z1 is 1 sorry, and d is minus 3, because we have to compare by ax plus by plus cz plus d equals to 0. So from here, so that would be, we have to take over here minus 3 equals to 0, so d equals to minus 3. Okay, upon under root a square plus b square plus c square. So a means 3 square is 9, b square is 16, and that is 144. Okay students, so now d equals to 3 3s are 9, minus 4 minus 2 plus 8 plus 12 minus 3 upon 16 and 9 25, 25 and 144 under root 169. So d equals to 9 minus 3 6, 6 or 8 14, 14 and 12 26 upon this is 13. So d equals to 13 to the 26. So distance from this point to plane is 2 units. Okay, very easy question, very simple. Okay, now you can solve the rest part. So our exercise 11.3 has finished. Now we will start the miscellaneous exercise of the chapter 11. Please pause the video and note it down.